Moving ocean water. Ocean water has three main types of motion: waves, tides, and currents. Waves occur when the wind blows over the surface of the ocean, pushing the water along. Larger waves are caused by wind blowing for longer times and wind blowing over greater distances. As waves reach the shore, the water depth decreases. The friction between the water molecules and the seafloor causes the bottom portion of the wave to slow, while the upper portion of the wave continues. As a result, the wave grows larger in height until it can no longer support itself and it breaks. So that's what you're seeing here. As the depth of the water decreases, this top portion of the wave continues moving faster, 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 making the waves higher until eventually the wave breaks. Tides. Tides occur due to the gravitational attraction between the Earth and Moon, Sun, and other celestial bodies. The Moon is closest to us, and although much smaller than the Sun, its proximity gives it the greatest influence over the tides. The Sun is larger, but much farther away. It will still influence the tides, but not to the extent that the Moon does. Other planets have small masses, considering the distance they are from the Earth, so they have only a very small effect on the tides. High tides. As the Moon's gravity pulls upward on Earth's water, the ocean rises on the side closest to the Moon, which you can see here. As the gravitational pull is upward toward the Moon, this is the high tide side. At the same time, the solid Earth is being pulled toward the Moon more than the water on the opposite side of the Earth. This creates high tides on the sides of Earth that are closest and farthest from the Moon. So we also get a high tide side here caused by the pull of the Moon on the solid mass of Earth, pulling it away from the water on the opposite side. So we're pulling away, so we're going to get higher tide here, and then also higher tide here because it's pulling on the water. The water level drops on the sides of Earth that are not on a line with the Moon and Earth's center. So if I draw a line here, those are my high tide sides. And so the low tide sides are the sides that are not on that line. So we have here on either side. So there are two low tides as well. Spring leap tides. While the Moon is the major cause of tides, since it is so close to Earth, the Sun also has an effect. When the Sun and Moon are in a line, tidal changes are much larger. These are called spring or leap tides. These occur during new moons or full moons. Shown here is the effect of a new moon. The same effect occurs for a full moon. So what we're getting here is the combined gravitational pull of the Moon and the Sun. And so we get these even larger tides based on that gravitational force pulling. Neap tides. When the Sun, Earth, and Moon form a right angle, as you can see here. So here's the Moon, here's the Sun. The tides are the smallest since the pull of the Moon and the Sun fight each other. These are called neap tides. The same effect is seen if the Moon were on the other side of Earth, but still at a right angle. So if I had the Moon over on this side. Neap tides occur during quarter moons. So you can see the water being pulled in this direction by the Moon, and that would happen on this side as well. And then on this side by the Sun, which would happen on this side as well. And these neap tides are the smallest, and they occur during quarter moons. Currents. Ocean currents are the large-scale circulation patterns of the ocean water. Ocean currents are driven by differences in water densities due to temperature and salinity or salt content, called thermohaline circulation. Water which is colder is denser, and water which is salty is denser than fresh water. Cold, salty water will tend to sink, and warmer fresh water will tend to rise. Thermohaline circulation is driven by the density differences in the ocean water. So these ocean currents lead to what's known as the global or Great Ocean Conveyor Belt, where we have this movement of water kind of along a conveyor belt. The red lines represent, so you can follow the arrows, represent warm currents along the surface. And the blue line represents cold, deep water currents. So cold and salty, deep current. And then this is a warm, shallow current in red. Ocean currents are influenced by a number of factors. Due to the Coriolis effect, currents bend toward the right in the northern hemisphere and toward the left in the southern hemisphere. Prevailing winds direct the warm surface currents. The ocean bottom and continental coastlines create pathways and obstacles for the water to move through and around. The Coriolis effect, prevailing winds, ocean bottom, and coastlines result in this set of ocean currents. You can see some are warm water currents. We have this north equatorial current, southern equatorial current. You can see the difference in the directions of the bending due to the Coriolis effect, and so on.